So let's see if we can cheat ourselves. No, we're not going to be cheating. We're going to be playing with software bill of materials. And just to give me a general idea of what's your experience with SBOMs. Anybody used it before? 0 people. Okay, so this is a perfect talk. Cool. So you're going to learn a lot. Okay, so let's see. So hi, that's me. I'm a consultant working for a company called thePHP.cc. We are with the 3 of us, and one of the more famous one, that's Sebastian Bergman, the author of PHP Unit. And yeah, we help teams, small, large, local, remote, wherever. We have like independent freelance developers that we are supporting as a, well, coach or pair in discussions, and large entities, enterprises, whatnot. So if you have any PHP related question that might need some more digging into, or architectural questions, we are potentially here to help. But that's enough marketing. We're going to be here for something else. So we're now working on SBOMs, which is the abbreviated version. I think it's SBOM or SBOM. Well, I say SBOM. So the basic idea is that we need to understand what our software is made of. That sounds not very surprising. If you consider like food, you at least at some point look into the ingredient list, right? That this is what this thing is made of. If you take a recipe, that's the things that you need to add. And for software, we for many, many years were just adding dependencies by Composer, Require, or NPM, whatever, or any other programming language, and just added things. And the scary thing is, we don't really know what ended up being part of our software in many cases. Because if you see a news report like, hey, this library has a security vulnerability and now so and so many applications are affected, most people are like, I don't use that library. Except you do, because it's a dependency of your dependency, or a dependency of your dependency of your dependency. But you didn't know. Because, I mean, who would check the vendor directory for all the libraries, right? I mean, you just install it and then suddenly half the internet is there. So, in short, an SBOM is a structured inventory of all the things that make up your software. And the reason why it's supposed to be structured is because you as a human may have a look at it, but you don't really care too much about it on a daily basis. You want to have tools be able to understand it. So you need some automated way of processing it. So why would I want this? Or maybe not that blunt, maybe why do I even need that? And one thing I already mentioned is like this security kind of thing. But of course, it's also getting a better understanding of what actually is my software. And there's a bunch of things that are potentially relevant. The first thing, maybe not considered the most relevant, but still to me quite important, is the aspect of transparency. I want to understand what the full supply chain of my software actually is comprised of. Or to make it a little bit less buzzworthy, I want to know exactly what libraries, components, and of what versions those are that I actually use in my software product. And this may be more recursive than you originally might have expected. I just mentioned Composer as one thing, or NPM as another. But in general, of course, this is not running in isolation. You're going to have PHP and certain extensions. Those extensions have libraries. Those libraries have other dependencies on glibc or muzzle or whatever, and they come with a whole operating system. So there's a recursive stack. You might actually have a web server included. You might have a database. So there's more stuff, and it gets bigger and bigger, and different environments need to get combined. So there's a lot of stuff that you actually use, or your software uses, that make up your product in case you want to ship it. Which leads to the secondary concern that you might have to face, depending on what software you're creating and whom you're going to deliver it to. Because there's a lot of compliance things that you may actually have to consider. The first thing is to understand what kind of licenses are actually included in your product. Because particularly if you use components, like by using Composer or NPM, There's a lot of open source stuff that you include, but it's not all like open source is everything and you can just do whatever you want with it. There are licenses and certain types of licenses attached to that. So that may mean that you actually combine a set of components that you may use but are not allowed to redistribute. There's an interesting example from a couple of years ago, actually, but still it serves as a very nice example, at least I think so, is about MySQL and PHP. You might remember that PHP has its own license, the PHP license. And while that is technically an open source license, it's not necessarily the same as the GPL. So MySQL was dual licensed. You could either say, I want to have a commercial entity because I'm going to make money selling a product that contains MySQL stuff, or I'm just going to be a user and then I can use that as a library using the GPL license. Well, that's fine, but combining the two together is a problem. So if you were to put a product on a CD or a DVD or whatever and physically ship it, or put it into an archive and ship it to somebody and get money for it, then you're selling it. So now you're bundling MySQL because you're technically using their library, because your PHP code uses the MySQL extension. So what do you do? Well, technically you would have to buy a commercial license, which nobody did, of course, but the PHP project solved it by basically not using libMySQL anymore, but just implementing the protocol in a native driver. So this is a solved problem. But in general, you might have that problem very well if you combine various things together, and they all have individual licenses, and they may not actually be compatible with each other or may not be fit for the purpose you're trying to use that particular piece of software. So in a larger entity, it's quite common that you have like legal departments requiring you to provide a list of all the licenses of the product that you're using, and they're going to say, yes, you can use it that way, or nope, not going to be an option. Then you have to find a different library, or you have to talk to the authors if you can get a special license deal for that. It might also be that you are in a restricted environment where certain types of libraries or licenses for those libraries are just not permitted. So again, you need an automated way to verify, like, hey, you're complying with the regulations. And if you have to do this manually, that's quite a lot of work. And it's really interesting to see how many companies have an understanding of what they are using without actually understanding why they are using it. In case anybody in here remembers the Log4j kind of security thing that like killed a lot of Java-based applications. And as part of the PHP unit project, we literally got 2 companies asking us if our product would be vulnerable to this kind of thing. Like, you realize this is the Java library and we are PHP, so no, we are not, and we're not using it. So to me, that was interesting in 2 ways, because first, they knew that they are actually using PHP unit, so they had a process to ask us as a potential vendor on what is the status of your product. And on the other hand, they had no idea that this is unrelated to their tool stack at all. So they have some understanding, but not really in a perfectly structured way. If they would have had an SBOM, they could have followed the dependency tree and would have seen, like, okay, there's no Java anywhere in this, so it cannot be relevant. And Log4j would not have been included in our dependency tree. But in general, this is really helpful to know and have this as a structure. And yeah, given that we already got in the direction of security, that's also really helpful from a security perspective, because in an SBOM, you of course want to know that this library and this version is included, or this component, or whatever dependency reason there might be. And yeah, figure out whether or not this is the current version, and if this is maybe riddled with any kind of security problem. So there are interestingly a lot of databases, some that are really being argued about whether they should continue to exist because of like some stuff happening in the US. We're not going to go into details here. But in general, there's databases where you can look up like this particular exploit against this particular version of the software. And this is public knowledge, but you need to map that to the software product that you're actually using. So as I said in the introduction, if you're going to notice because something is really big and somehow the press got news and made it in a big important report, you realize maybe I have to check if I'm using this, but this is something you cannot do on every day for any tiny kind of security thing that might exist. So having a structured information like this is the library, this is the particular version, and then having an automated way to look up into databases like, hey, these are known vulnerabilities. Does that match to the version that I'm using? No, everything older, fine, I can continue working. Or nope, there's a problem known in this particular release, maybe I should update. Yeah, and all of this, giving it structured, leads to the fact that I want to automate all these things. So that requires me to actually have a process in place that can generate all that stuff, because I don't want to manually type this, right? I mean, if I use composer require whatever, then manually have to edit some other file to just tell the system it's included. This is never going to work. This is going to be outdated the next day. So we need an automated way for all of this. And we need an automated way for scanning and telling us, so getting all the updates and all the information all the time. So the best thing you could do is simply introduce continuous integration and make that part of the CI/CD pipelines. So include the scanning for CVEs, like the standard known database vulnerability thing that I just mentioned, and making decisions based on that. So if you say, okay, I found that your component X has a security vulnerability which is rated with whatever kind of score, which I consider low, then ignore it and push anyway. Or like this is high, and like, oh, maybe that's a problem, then I should actually stop this from being released. Or somebody has to explicitly force the release because we know that this is a problem, but there's even worse problems that we need to fix right away, so we don't skip that security problem for later. But you need to have an automated system in place to actually do all that. We don't go into how to do this in detail because that would basically, not be possible in the time we have. But in general, it's not that hard to set up. Okay, so now we know why we might want to use it, or maybe even require to do so. Let's see what the world says about SBOMs. There are some guidelines and some organizations that basically came up with rules what might be relevant. Despite the standards itself, we're going to have a look at how they look in a bit. What would we actually require for processes and compliance reasons to be included in such a thing? And the first thing that I found was from the NTIA, the National Communications and Information Administration, typical US name for an agency, I guess. They came up with some rules and they documented them in a nice PDF. I mean, why would you use web? But let's just publish it as a PDF. But hey. And they came up with a set of so-called minimum requirements. And they say for anything that you use, I want to have a component name. I want to have its version. I want to have an identifier of the supplier. I want to see the relationship, as in where is it in the tree? Is that like the first level kind of thing? Is this my application, or is it a dependency, or the dependency of the dependency, and so on? I want to know who actually created this SBOM. I want to know when it's been created. And I want to have unique identifiers for all these kind of things. And what these individual things mean, we're going to have a look at in a bit. Which kind of makes sense, I guess. But of course, some of these informations are like generic strings that are just useful to look at as a human. The most relevant part is this thing that's currently unspecified. It's the unique identifier. Because I want to be able to map this particular piece of software component with whatever is in databases. So I need to find it, and doing a fuzzy search by name is probably not going to be very helpful. Also, it doesn't really specify how a version should be specified. So it could be anything, which made quite some people pretty angry because like, hey, there's VMware, let's use VMware, but no, we're going to do this, we're going to follow some other mechanism, and yeah. But I guess in general, that makes kind of sense. Then there's the CISA, which is the cybersecurity agency in the US. And they basically said, do whatever the NITA said. That's good. But keep in mind that we want to use this basically for security things. So keep it up to date and make sure that it contains all the information relevant for us to actually do the security scanning things. And they basically say we need one of the two formats, which is Cyclone DX or SPDX. We're going to see how those look in a bit. That's the two standards that evolved basically from all the standardization processes. And they specify a lot of best practices. Okay, this is how you should do it when you do this kind of thing. This is what you should do when you follow it this way. Then when you do it in this kind of environment, and when those kind of regulations apply, and so on. And most importantly, which I'm not going to cover in detail today, is the validation and attestation. Because the SBOM is a list of ingredients. That's nice. But who says that what you actually have as a product is what is written here? Right? I mean, I can say this is the latest version of everything, but I'm going to bundle a Stone Age version of the same library in my component. Hard to figure out. So that's why you can validate things. And I have to sign off that this is what I vouch for, that this is the current and correct state. It's pretty much like what you sign when you sign a legal document, right? I, as a signee, say this is the truth, and well, if it's not, then I might get sued. And yeah, all of that needs to get into secure processes being implied, but that's not too relevant for Europe, I guess. And there, of course, given that there's now recommendations on how you should be doing it, but nobody was adhering to them. I mean, why would you follow a guideline or a best practice, right? I mean, we are IT people, we do whatever we want. Doesn't have to make sense, must not necessarily be the smartest thing to do, but it works, so let's ship it. Well, given that didn't work, and people didn't really adhere to it, the United States, as one of the first, interestingly enough, decided to do something about it. And you may or may not like it, but the Biden administration did a few good things. One thing was the executive order with 14028. And that's a rule that says if you want to ship any piece of software to the federal government or any of its affiliated agencies or companies, you have to supply an SBOM. And if you do so, this is the rules that the SBOM has to fulfill. So basically, this is pretty much exactly what the NTA said. What they added was like, hey, let's add hashes of these things. So we know that what we actually have in this document adheres to what is actually in the product that we got, which is a smart addition. And they said, okay, we want to use exactly the same things as the recommendation, well, suggests, as in SPDX and Cyclone DX. But we're also going to allow SWID, whatever that might be. We're going to have a look at it in a bit. So while the first agency said like there are 2 recommended formats, this is now basically 3 that are accepted. So having 3 versions that you could use to specify the dependencies and all the versions and all these things in an SBOM style format. If you are in a more stricter regulated environment in the US and want to ship stuff to the FDA or any kind of medical things which the FDAs are monitoring, that's the Federal Drug Administration, so anything medical is run through them. You have additional rules. They basically want to have the same information included, but they be more specific in what actually the list has to contain. So you actually have to specify any open source or third-party libraries independently from what is actually your code. And they want to have additional plans. Okay, how do you deal with certain vulnerabilities or problems, and what's the process to contact you in case there's a problem and things like that. That all can be documented using an SBOM. And in case you wondered if this is the brand new thing, well, not really. The original work has started in 2010-ish, but the SBOM requirement, as in this executive order, is from 2021. That's when it's effective. So by now, basically for 4 years, pretty much, this is what you have to do if you want to ship any software to a federal agency in the US. But we are not really in the US, we are in the European Union, right? So we have something similar the Cyber Resilience Act. And that applies to pretty much any product that has some sort of software involved. So I guess that's us. And basically they say, okay, you know what? We're gonna do exactly the same as all the others are doing. We're just gonna change some small details. But it boils down to like, okay, we wanna have a list of software components being used. We wanna have their versions. We wanna have a supplier and a source address where to actually get this software potentially from. We wanna have the license information as a requirement. So this was something the others didn't necessarily require, but would make sense to have anyhow. And when we want to know if your product has any known vulnerability at the point of shipping, which makes no sense to me at all, because that's a red flag, right? I mean, I know this problem, but I'm not going to fix it. Here's the product. Shipping with a known defect kind of feels weird, but maybe that's exactly the reason it should be empty. And well, and they require, interestingly enough, this one has to be kept up to date. However, that's supposed to happen, I don't know. The documentation I read about it was really vague, as always, with like EU regulation documents. And I'm not sure that the person who wrote this actually has any idea on how this should work technically, but the idea makes sense, at least from an outside perspective, like, hey, I want to know that this is the current state of things. But if followed by the letter, at least as far as I understood it, that would imply that I have to regenerate this SBOM every time somebody requests it. And if something that I created like 5 years ago now magically got a security problem, that SBOM now should include it. At least that's how I understand it. I'm not sure that makes sense or anybody would actually do it that way, because I would just ship a new version of that product, but hey. And interestingly enough, you don't necessarily have to ship it along right away. It only has to be made available upon request. So useless, but hey. Interestingly, this is in force, as in became actual a legal requirement in the European Union in the December last year. But it wouldn't be the EU if there wouldn't be a loophole in there, because you can actually not sue anybody for having it until December 27. Because we need to give the companies more time to do something they had been knowing about for 10 years, right? Yeah, welcome to Europe. Okay, since we want to do a little bit of hands-on stuff still, let's quickly go through the various formats. And I'm going to basically skip on this SWID thing because I think it's pretty useless, because nobody really supports it and nobody really needs it. But there are two basic things. The first one is the SPDX, which has been standardized. Woo! We know it's an official standard by the ISO under this very easy to remember identifier. And it's been created by the Linux Foundation. They have their own work group for that kind of thing. So that sounds like pretty good. It's an ISO standard. It's a known organization behind it. So cool. It comes as a JSON and XML format, which is the usual thing that happens if people are fighting. And like, we know this is the information we want to send around, but it has to be presented in XML. No. XML is stupid. We have to use JSON. But JSON has all these issues. Let's use XML. And well, if you can't agree, you just do both, right? So now we have the same information represented in two different serialization formats. Awesome. Or not. It was announced that, hey, we are going to be working on this because it makes sense to actually have something like this in 2010, and the initial release was 2011. So it's been around for a while. And then there's the other big standard, which is called Cyclone DX. And that's been also a standard. But of course, a competing standard, because it's, of course, not identical in any way. It's an ECMA standard, so the same as the organization that standardized JavaScript, which also really helped and not, well, never mind. It was created by the OWASP Foundation, which may be known for the top 10 of the security vulnerabilities they keep updating every year, even though nothing really majorly changes because people are somehow reluctant to learn. but maintenance has been taken over by the ECMA standardization group. And it also comes as a JSON XML format because reasons. So that means if you want to work with any type of SBOM, you basically have to write 4 parsers to handle the exact same information. Yoo-hoo. If you're not happy with the standards, you can also use binary protocols or even CSV. Yeah, okay, let's not go there. The cool thing, though, is that CyclingDX allows to have custom properties added to it without actually violating the standard, which I think is really practical because you can add things and then later standardize them on top and actually have something that you can, well, get into the market and, well, maybe get it a bit more mature over time. And if you realize, okay, this is actually making sense, we can make it start adding part of the standards. So what originally XML and to some extent HTML was for. So that's cool. So we know that there are basically 2 different formats. They basically are JSON structures and contain the same information, just using a different structure because reasons. But of course, they all need to be able to identify a certain piece of software. So we need a unique identifier, and it needs to be something that other people use as well. So it would be not helping if we have a standard that works for us, but nobody else uses, so we actually have to find a way to translate it. So there's independent standards for identifying a software product. And of course, there's more than one because, I mean, we are in the IT world. Why would we have a single standard everybody can agree on? So the most known standards are CPE, Perl, and SWID. And as I already said, I'm basically going to skip the SWID part because it's not necessarily that relevant in most cases. There are some edge cases where, particularly certain environments, where certain types of regulations where you need to have that version, but most of the others basically support CPE and Perl. So the most common one, also given the name, is the Common Platform Enumeration, or CPE. And that's originally invented and maintained by the NIST, which is also another US agency to do all kinds of internet and standard and norming things. And they came up with a format that has the identifier, or what it is, has the version for it, and then like vendor, product, and version, and whatever asterisks are there behind. I have no idea. I didn't actually find that while quickly trying to find what the asterisks mean. But apparently this is always identical copied. So maybe that's reserved for future use. I have no idea. If somebody has a better clue, please enlighten me. I would like to know, but I didn't find it in the documentation. But maybe I didn't look good enough. So in practice, that looks like, okay, this is the vendor, which is in that case Nginx. As a company, the product is also called Nginx, and then this is the version number. And that's a pretty unique identifier for this particular piece of software. And if you follow security vulnerabilities in like all the standardized databases, like the CVE thing, for example, then you have this as an identifier there as well. So it's an easy thing to match to find out what actually version you're using and what the version that is potentially vulnerable is, and then say, yep, we're good, or nope, we have to update. But this is a US organization, and people are like, well, US organization, let's do something different. So there's also a project that's called package.ul, or Perl. And that's actually maintained by the open source community at large. So somebody started it as an open source project on GitHub. And more people are adhering to that standard and updating it and working together. And more people are actually starting to use this format. So maybe in 50 years or so, we can get off the other one and only use this one. I don't know, but that would be really nice to have. So basically, this is like, it's a package. It says what type it is, the namespace as in where it's coming from, the name of the actual thing, and at the version thing, which may look familiar to what you use in Composer and many other tools, because that's the standard way of specifying what thing you want to install and what version. So an example would be to have a package as an RPM format on a Fedora Linux distribution, saying the package is curl, and that's the particular version, and whatever additional details that you might add to it are more or less optional. In this case, it's a really old Fedora version and an, of course, really old architecture thing, but this serves as a purpose. I gave the 2 URLs below here, and there's a URL for The PHP implementation, if you want to parse these things or generate these things based on things that you know about your own product, that can create that particular format string. Yeah, and there's this SWID thing, the software identification tag, which is a ISO standard. And instead of something that is readable by itself, it's a .swid tag file, which is an XML file that contains all the information about this particular piece of software in itself. So you would have to combine all the individual files to basically get the SBOM information joined from that. So this is not really just an identifier, it's more with the tag that contains additional information. And I was looking for an example, but everything was so large that I've said that's not going to fit on a slide, so that's not going to show it. Okay, so I promised hands-on, and I think we have like 15 minutes left for that. Perfect. So let's see if the demo gods are with us, because I created something ahead of us. Oh, let's just close that one and create a new one. Let's close this one as well. Where's my window? There it is. Okay, so no CD. Is that actually readable in the back, or is that too small? Works? Okay, cool. So let's create a source directory and a public directory. And let's install Composer so we can use that. Tools, Composer, require monologue. Yes, this one. And let's take Guzzle. No, one. Okay, so we have some tools installed, and we can see it's a very sophisticated application. It has 2 dependencies. But of course, there's more stuff that appeared in the vendor directory. So we actually have dependencies of our dependencies. Not surprising, but well, it's more than the Composer JSON admits that it's there. If we look at the log file, we can already see there's a lot more information. And the interesting thing is that the majority of things written in here already follow what we need for an SBOM. It's just not in the right format. So basically, we need something that transforms that and comes up with the identifiers as the SBOM standards require us to do. And let's install something from NPM. Let's do something small. So now we have a package JSON, something simple, and it doesn't even have any dependencies, which is unusual, I guess, but I don't want to overdo it. So now we have a few things installed, and in general, we need some container, I guess, to actually run this. So we could use a standard PHP container. And yeah, given that we do not necessarily want to do any kind of really complicated thing, let's just use the standard one and directly create an SBOM for the container. And there's a nice tool called Sift. And as you can already see, when you start this, it's, well, designed to create an SBOM of container images and file systems. And I can basically give it a list of parameters of what I actually want it to create. And I can just show you how that looks. So this is not readable. So let's run this to JQ, just because I don't want to use JSON pretty. So this is the standard output of an SBOM for the Alpine image as in the latest thing. And you can see it's already quite long, so there's already a lot of software included. So long list of components and things that are included in an Alpine image, but it contains all the information that is potentially relevant to understand what is actually included. So it has references to what layer it was built in and of the original image, hashes for all kinds of things. Let's go a bit more to the top. So here you can see the identifiers, and those are the IDs. And you can see it's everybody has like asterisk, 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 asterisk. So I don't know, maybe it had to be padded to a certain length. I don't know. So this is the list of components, and then there's the dependencies and what libraries are included. And so, yeah, it's a lot of stuff that's in there. Okay, so instead of putting this into onto the screen, let's just do this as a JSON. I should have actually told it to put it into a file, because now it's going to dump it on the screen. Yeah. Container SBOM JSON. So let's scan this again. And it's already interesting that you see this is the standard FPM image that if you use that without the Alpine aspect, it's Debian based, and it has 879 executables included, which is pretty big for just having PHP, right? But that's a different talk. Okay, so we know this, so that's cool. So, but that's just the PHP FPM container. It's not the rest of the application, so we need more data. So what we can do, and I'm going to, well, nope, not going to go back here. I'm going to cheat a little bit, because I prepared this. Because I don't want to type all these things again. I installed all these things. Where's the composer thing? There it is. Because we need to convert our composer log thing. So let's install this as a dependency. Yes, we're going to trust it. So this is a, on the Cyclone DX project, there's a PHP Composer plugin that adds custom commands for us to actually generate an SBOM. And I'm just going to copy this from here as well, so not to waste too much time. And interestingly enough, their default is to use XML format. So I'm explicitly saying to use JSON here, despite me being a big fan of the XML formats in general. So let's just do this. And this is really quick because it has everything already in the composer log file. It just has to change that format. And this is how it looks. So we have the dependency graph, and we also have the individual identifiers in here where stuff comes from. We have the CPEs included. So this is all the standard things that you might expect. So yeah, it goes relatively quick, but it's still a lot of text that's being generated, as you can see. So this is certainly stuff you don't want to read at the human being. At least not on a daily basis, unless you're writing tools for it, I guess. Okay, so we have a SBOM for our container. We have an SBOM for our composer dependencies. Now we need to do the same thing for our npm installed thing. And at some point, I'm going to keep remembering using the correct key shortcuts. So one thing that you can do is also from the Cyclone DX thing, you do the same thing with not composer, but npm. So just install that as a dependency and then run this. And it also generates an npm SBOM. npm SBOM. And it looks surprisingly familiar, I guess, but that's the same thing. And you can also see here there's the Perl identifier included. So that's exactly generated from the log files as well, and the processor who created it. So now we have 3 SBOM files, which is nice, I guess, but to actually have an understanding of what our actual full software stack is, we cannot add like a random list of just whatever bunch of files. We can generate that as a one single file, so we can merge that. So there's command line tools for that as well. So we can tell, okay, using this CLI tool, let's just merge that, put it into a merged SBOM file, and take these input files. And let's see if that actually works. Yes, it does. So now we have one SBOM file that contains 8,057 components. And I just installed 2 packages. So if you ever had anybody tell like we are working without any dependencies, they're probably lying. Hopefully not intentional. Okay, so we have the merged SBOM, and you can see the file is actually comparatively big, but makes sense if you combine all the information. Okay, so now we can do something fun with that particular thing. And the nicest thing you could do is put that into a tool that actually renders it and analyzes it for you. And I did this with the previous version that I generated for testing purposes. There's also CLI tools to actually upload this into a tool like Dependency Track, which I'm just showing here, which is an open source application you can install. It's a Docker container if you want to, or it's a full pod or compose, whatever kind of environment you are happy with. And yeah, you can create a project here and then just upload the SBOM file. And yeah, you can see the assessment. And despite me literally doing this yesterday to have the latest version of everything, I have 1 critical, 3 high, and 1 medium security issue in my installation already. So let's have a look. And this is the list of all the things that are included. This is obviously a very long list. We can see a dependency graph, which may take a bit for it to render, so we're not going to go there. But the most important part is the audit tab, where we can see like, hey, we have Perl being affected by this CVE, and basically we have Perl and package conf being medium. So the current image that you can get from the Docker Hub for PHP has a high vulnerability in Perl included. Now it's up to you to decide if this is something you want to ship or not, or if you think it's too risky. Or maybe you want to use a different container as a base. You can get more details on the individual CVEs by opening the tab here. Yeah. There's also a list for the licenses involved. And you can see already, this is in the 8,000 something components, we have, well, 757 different types of licenses. So have fun, legal department, right? So yeah. And the cool thing is that this is going to be doing this continuously, and you can, of course, include this. There's a lot of things that you can do in an API and verify if it's like the general project risk, and if you think it's good to go, or if it's not ready, or if you need to raise an alert, open a ticket, whatnot. So this is where automation comes in place. But tools like this make a lot of sense because, well, 8,000 something components you're not going to review by hand. This is just impossible to do. Okay. There are more tools that you can use than just the ones that I showed. One is called Gripe, which is basically doing the same thing as the dependency track thing that I just showed, just on a CLI. So you can see in the output here, it's basically analyzing these things as well, and then gives you the output of what it found. So basically, that's the text variant of the HTML interface. There's SecObserve, which is also comparatively known, providing interface with but also with history, so you can compare hey, we increased this level of what updatedness, if that's a term, or we found things over time and they got remediated quickly and all these kind of statistical things, which I think is pretty nice. And then there's Trivy, if that's the way they pronounce it. That's scanning things, and you can also do this with other things than just container images, so that's potentially helpful. A lot of tools are actually used intermediately, so if you use deptrack as a dependency track, they also use Trivy and other things in the background, so that might also be helpful to know. And we have the general SBOM utility, which is allowing you to, modify, validate, patch, sign, whatnot, kind of things. So you can query things and see what kind of details you want to get from the SBOM without actually reading the source code or writing a tool yourself. So this is really helpful if you want to automate processing yourself and basically query this without finding out a potential harder way if this is the correct version that you wanted to have installed or whatnot. Yeah, and that's the hands-on and quick dive into SBOM. And I think we have 2 minutes left for questions.